Okay, hello everybody. My name is James Guilliatt. I'm a project manager in the transport systems team at the City of York Council. It's supposed to be just on Glosa, but we've done so much great work in STEP and shoehorning some other work in there. Given the time constraints, it's going to be a bit like one of those Christmas family games. I've got 30 seconds to try and get through it, but I'll do my best. Questions at the end if we get any time. So what is STEP? It was a successful bid to the DfT for National Investment Productivity Funding. And the main aim is to prepare York for connected and autonomous vehicles, enable next generation of traffic management, and open up our data sets. We've done this by unlocking all sorts of data sources from around the city, building a data platform, some of the data types, which I'll run through in a moment. Interesting. We have a prototype which has been running for a couple of years now and is currently live, which was built largely by John Wade, so big shout out to John, who's done some great work, which you'll see in a minute. And Alcera Technologies, a couple of guys sat around the room, or maybe just Aaron now. That's really annoying. Oh, am I stepping on the stuff? All right, sorry. Yeah, so I'll run through some of the data types. I'm conscious of time. But with the non-prototype, the sort of Alcera version, we're hoping to then bring in more carved denim, the BODS data, all that good stuff. So, what we do?
So I just think that's not connected to speakers. So that. I have that you can leave because that's nothing. I have no idea what it is.
So it turns out I'm radioactive. I'll just crack on and you'll go with it. So what we're doing with the data, we have it in our prototype system. We're trying to stay.
If in doubt, give it a good bang and see how that does.
Okay. There we go.
Yeah, it's definitely PA mic. Yeah, just shout. Turn the PA mic off and shout.
Thank God. All right. Can everyone, the guys at the back, can you hear me as I'm speaking now? Okay, right, Mark 1 voice, that's what we're going to have to go for. So what are we doing with the data? We have it in our data platform, which our engineers can use. First type of data I want to talk about is traffic flow. So that's counts of vehicles crossing certain points. We have 100 traffic flow counters in the city, about half of which are reporting back within 1 minute latency. And then we're using that in an aggregated 5-minute timeline to see what's happening around the city. We can then feed that into our optimal real-time model, various bits and pieces about real-time modeling. This has been deployed since spring. This is an actual thing that we use. It's really good. So the first thing that we do is stick in the flow count. We also have the flow information, which we use for our engineers, and we send to the likes of the DfT for the updates on travel around the nation. The next type of data, which is most exciting to me as a signals engineer originally, is the signal data. So we had a few comments today about the signal data is all locked in to the UTC systems. How do we get it out? How can we use it? For example, the graduate wanting maybe a set of cycle time data over a certain period. We collect all of that by sniffing the SNMP packets from the controllers to the TMS, to the traffic management system, and we have it in our data platform. So you've got the stages running here, you've got the phases in the stages, and probably can't see, but there is also demands as well. So you can see a demand going in. Oh, it's being serviced. There's that stage running, and we've got that for about half of our signal sites now. And that is also fed into the real-time model. we have floating vehicle data, so live speed data. That's also fed into the real-time model. So we've got all these layers of real-time data in our real-time modeling, and that's every 5 minutes. Again, quite up to date. And on top of that, we can layer our roadworks. So we've got a GUI that we can render it ourselves, and we're currently working on getting the roadworks information automated from the likes of One Network. There's a bit of work to be done there. So at the minute, we enter it ourselves. And what we can do with that is run some scenarios with the live traffic conditions and say, okay, if we do these roadworks and make these closures, what's the reassignment of traffic going to be like? What can we do to mitigate any problems? So the benefits of that, it's been discussed a little bit already today. So the network monitoring officers only have a couple of pair of eyes, only so many CCTV screens. They can't watch the whole city at any one time. But by having this real-time model, they're able to see pretty much the whole city. And if bits start going red, a little bit like Google Maps, but I'd say this is Google Maps on steroids, because Google Maps doesn't have 100 flow counters. Google Maps doesn't have all the traffic signal data. And Google Maps doesn't have our network monitoring officers keeping an eye on the cameras as well. We can then also pull out some KPI dashboards. So you've got some dashboarding there. You can do all sorts of stuff. That's just an example. You could draw a corridor, for example, journey time. What's your average journey time? Is it exceeding the thresholds? That sort of thing. You can pump that KPI data to third-party systems as well. So one thing that we're looking at is, okay, we've got journey time KPI on this corridor. When that gets exceeded, let's send a message out to the traffic management system to set plan or whatever. So that's not happening right now, but that's the sort of the roadmap for the future for making automated decisions based on KPIs that our engineers and network monitoring officers have set on the city. So again, benefits, we can test scenarios. The network monitoring officers are able to see what's happening in the city at much better detail than sort of publicly available services. And there's loads of other cool stuff we can do. So if we can start squirting BODS data into there, we can see how the buses are being late. Okay, what if we change some signal plans? Is that going to ruin the rest of the city? Okay, maybe it is, but it's worth it for these buses, or maybe it isn't. It gives the policymakers those tools to be able to decide what they want to do. And I'm now on to the thing that I'm supposed to be talking about, so sorry for rushing that and the random crisp packet noise. So, GLOSA, another part of the project, or the main part that I'm supposed to be here to talk about today, is Green Light Optimal Speed Advice Service. There are different variations of that acronym, but that's what we're going with today. And for those of you who don't know what GLOSA is, it essentially displays the live signal heads currently in an app for a driver, and gives them an advised speed to travel at to get through the next set of signals on green. On sites where it's too hard to predict what's going to happen next, say mover, things like that, currently you get signal head information but no prediction, because the prediction element becomes very difficult. I know there's some guys in here who are working on that challenge. But for the simpler predictions, we can utilize like demand bits. So vehicle approaches a certain road at a set of lights. We know that's going to get called. We can make a prediction based on the timings as to what the other road users' signal timings will be. So what's GLOSA in York? We're deploying the service via Dinnick's Caflo. We'll be the first place in the UK to have GLOSA to the public. So undoubtedly there'll be all sorts of interesting and wonderful things coming out of that. But despite the challenges of releasing something innovative to the public, someone's got to do it. And we want to learn, how will the public perceive this service? What will the challenges be in operationally trying to keep this alive for a number of years rather than at a trial site? And then sharing all that information, the likes of the Department of Transport, with other road authorities. So it is a trial, but we would like to have been live today on a sort of early access thing. I think some of you have got an early access app. Fortunately, haven't had the time to get the service up, or we could have done the dangerous, live, let's have a go today in front of everybody thing. There is a little video at the end for that though. I'll just mention, we also dictated that in the specification it should be over cellular comms. So there's the whole 5G, G5 ITS, cellular comms. We've gone for cellular comms, but a hybrid system, so we can install beacons if we want without any extra real hard work other than the kit. And that's because we want people to be able to use this service regardless of their income. So you don't need a fancy car. You don't need to install an onboard unit. You can just have a smartphone, which most people have these days, in any car and be able to use this GLOSA service. There's also the data will be available on our York Open Data Service. It's not there yet, so don't go looking just yet. And there is a software development kit. So if somebody wants to use develop their own app using the York GLOSA data, they can do. Caveat, I know at the minute there are some issues, there's a few interested parties in that, with it, the software development kit is available. However, the current sort of agreement to allow you to use that is a bit difficult. So we're working within it to make that as easy as possible. These are the sites in York that GLOSA will be live to the public. So you've got the A59 coming from Harrogate, the 1079 going out towards Hull, 22 sites in total. Different challenges on the corridor. A59, some of the sites are bunched up close together, which can make it challenging for displaying information between sites. And the 1079, we have different challenges, such as slightly flakier communications and things like that. We're currently in the process of site acceptance testing these. Works a treat in the sort of test environment, but once obviously we take things into the real world, there's all sorts of funny things that happen. So we're just working through those. Here is an example of the Caflo app. So on the right-hand side there, you can see this is the advice. So there must be a maximum speed limit of 40, which there is. So in this case, if you travel 40 miles an hour, you'll get going green on any of these. Got a countdown bar of what's left, the green time or the red time, the speed that you're actually doing at each moment in time, and it's connected to the service. Some of you may be thinking, well, why do you want to show what the signals are doing at people's speed to try and beat it and that sort of thing? Start speeding, all the information's removed from you, just get the speed limit. So we're trying what we can to make the service safe and stop people from abusing it. On the right-hand side there, you can see that you can have the app as a pop-out over sat-nav services and other sort of applications. So you don't have to have loads of phones to do loads of things. You can have it on top of your sat-nav, etc. So let's see if this video works. I don't know.
Should just work if you press
Space again. Okay. I'm hoping this is muted because I was chatting absolute nonsense when we were videoing it. Thanks to Aaron for being there. Camera holder for me yesterday. So this was taken in York yesterday. When you approach a set of signals within 100 meters, it removes the information because we want people to look at the signals on the road, not at the app as they're going through it. Again, as we approach the junction here. Eventually, it'd be nice to have that in the head unit, get the OEMs interested in all that sort of stuff, but we're not just quite there yet. For those of you that are interested in how it works, I don't really know how I'm doing for time. We've got the traffic signal controllers. They're all feeding the information to the management system. That goes into Guilliatt's cloud. The ASCII service can then provide that data back to our open data service. Send it to what would be a roadside beacon, virtualize those. So that's a virtual roadside beacon. Hence, you can have that onto a physical roadside beacon switch. And that then goes into something vehicle the flow sense, where they put all sorts of vehicle data that they have in Netherlands and that sort of stuff. Hopefully be available to the UK shortly, and that's what the app communication flow sense. So the signal phase and time information all the way through, matched with some mapping, and then that gets sent to the app. So 3-year trial as part of the STEP project. If it's successful, we'll continue with it, but we need to see how the public are going to perceive it and if it's actually useful. Try and measure some benefits and things. I know Paul Rose at Amy's done some good benefits measurement stuff on the trial that he's done, so maybe see what we can do there with emissions and things like that. And yeah, No plans for the city centre. The sites are too close together. You'll never achieve the speeds that it's maybe asking you to do if it's 30 miles an hour because of traffic and stuff. So very much corridor based is the approach that we've gone for. And I don't know if I've got time for questions or not. No,
sorry,
I'll
mate.
shoot off.
Who's on next?